Welcome back, guys. Today we will be doing mathematical induction where I'll be proving that the summation of I from 1 to n is equal to n over n plus 1 all over 2. Let Pn be the statement in order to prove this mathematical induction. So the statement is that we're going to prove that the summation from I equal 1 to n for I is equal to n over n plus 1 all over 2. So we can write a statement as what I've stated. Then we are going to prove when n equal 1. Because I want to prove for all numbers, so n equal 1, n equal any number, it will work. That's why I'm doing this proof. So to prove when n equal 1, I will substitute 1 on the left hand side because I starts from 1 and 1 on the right hand side. So substituting I to be 1 because it's 1 from 1 to n, substituting the 1 here, I will have 1 is equal to substituting n to be 1 here, 1 open bracket, 1 plus 1 all over 2. Now, on the left, just as I stated, the summation is from I equal 1 to 1, and I is 1, so I just replace it 1. Simplifying the numerator on the right, I will get 2 because 1 plus 1 is 2, and 2 times 1 is 2. But 2 into 2 goes 1 time, so here I have the left and the right being 1. So we have proven that at n equal 1, I have the left hand side being the same as the right hand side. So since I have proven that the left is the same as the right, we can say it's therefore true when n is 1. Now I have to now assume true when n equal k because k represents any number. So assume true for n equal k. So that's an assumption. So we're already saying it is true. Now it means what I'm going to do is replace the limit, the upper limit with k because I'm summing still from 1, from I equal 1, but I'll be stopping at k, whatever is k, because k will be the last value. So summation from 1 to k for I is equal to replacing the n with k, so I have k open bracket k plus 1 all over 2. So this is the assumption that, we substitute k because we're saying from 1 to k, it's true. And if it is true for n equal k, what about the next number? The next number will be k plus 1. So if it's true for n equal 5, will it be also true for n equal 6? So that's the k plus 1 term. So now I am going to prove if it is true for n equal k plus 1. I'll be summing from I equal 1 to k plus 1. So n is now being replaced with k plus 1. And we're summing I, but where I have n now, I'm going to replace it with k plus 1. So k plus 1 for n, another n, so I'm going to have a k plus 1. So replace here with k plus 1. And I'm going to have an extra 1. So replace n with k plus 1, then I have plus 1 all over 2. Now, after substituting, I will add the 1 plus 1, that's 2. So what I have here is k plus 1, and then we have another one that says k plus 2, and it's all over 2. Now I need to show that this left hand side is the same. So we're going to split it. So the summation from I equal 1 to k for I plus the k plus 1 term. Now, the k plus 1 term because I'm summing from 1 to k plus 1. That's above line. So if I split this, I split it as the summation from I equal 1 to k plus the term that is left off. So we sum from I equal 1 to k plus the k plus 1 term. Let me explain using numbers. Say I have the numbers 1, 2, 3, 4, 5, and I want to sum from 1 to 4. So the summation will start from I equal 1 to 4. So summation, the lower limit, I'll start at 1 and I'll stop at 4. Plus the fifth term. Well, this is saying the same thing as above. I've just split it so that I have the summation from I equal 1 to 4, which represents the first part that I have here, plus the fifth term, which represents a k plus 1. So I'm summing from 1 to k. That's what this means. Whatever k is, I'm summing from 1 to k. But I haven't left out the k plus 1 term. It's still there. So the k plus 1 term still exists. I've just split it. So this is still summing from 1 to k plus 1. So for here, the summation from I equal 1 to k comes from the assumption that it's the same as k open bracket k plus 1 all over 2. And then the k plus 1 term, I will replace I with k plus 1. So it will be just k plus 1 here. I'm going to find the LCM because I need to prove that it's the same as the right-hand side. So this is the right-hand side that I'm trying to get on the left. So I'll be putting this k plus 1 over 1. So finding the LCM for 1 and 2 is 2. So I have my 2 here. 2 into 2 goes 1 time. So 1 times k plus 1 is what you have here. Plus 1 into 2 goes 2 times. So 2 times k plus 1, 2k plus 1. Not going to expand this. Now k plus 1 is common. So let me put a square bracket because I'm going to factor out the k plus 1 that I have here. So factoring out, I have k plus 1. And what's left within the square bracket, since I factor out these two, realize I'll have the k plus 2. And then this plus 2 all over 2. So as you can see, the left-hand side is the same as my right-hand side that is in black. So making a statement, that's the next step that you would make, is say, proven true that n equal 1. And the assumption states shows that it is assumed true when n equal k, and it's proven true for n equal k plus 1, then it's true for all values. Thanks for watching. Don't forget to like and subscribe to my channel. Have a great day.